Okay, so it's been about 10 minutes or 9 minutes-ish, and some of you guys have said you guys are done. So let's start going over some of these problems. Okay. Does anyone know how to do number 1, where it says expand x plus y in parentheses squared? Who wants to give that one a try? Samuel, do you want to give the first one a try? X plus y squared. Samuel? How about you, Vincent? Number 1.
X plus y squared equals to x plus y times x plus y. And then you multiply x by both numbers and y by both numbers, and you get x squared plus 2xy plus y squared.
Exactly. So we start with x plus y squared, and then we have to expand it out like this, x plus y times x plus y, because when you're squaring something, you're multiplying it by itself. We multiply these two x's, we get x squared, then we get an xy, then we get a yx, then we get a y squared, okay? Some of you guys in the chat, you guys thought that x plus y squared equals x squared plus y squared. Do you guys see why this is not the case now? Okay, yep. Does that make sense? If you have any questions, feel free to ask now. So if you put x squared plus y squared for number 1, and you're still confused about that, raise your hand or ask now. Okay, unmute yourself and ask if you're still confused. Okay. Daniel, do you get it now?
Yes.
Okay, so what do you think the answer is?
I typed it. Wait, do you mean the first one? I typed it in chat.
Yeah, the first one yeah, but you typed the wrong answer in the chat. So do you understand the right answer now? Remember, you have to include these middle elements. Okay, you have to multiply x by y, y by x.
I understand it.
You understand or you don't understand?
Understand.
Cool. Sounds good. Did anyone try number 2? Number 2 is really tricky. Who wants to give that one a shot? Aiden?
Do you just do the same thing, but just with 3 x plus y in parentheses?
Daniel, do you want to give that a try?
Is it just the same as 2 of them, except that there are 3 of those things in parentheses?
Yeah. Let's try that, okay? So Aiden, do you want to ask your question that you typed in the chat to everyone so that everyone can understand the question that you're asking?
No. My question was just the one before about why why x plus 1 parentheses squared is not equal to x squared plus y squared. I'm just kind of confused.
Oh, okay, yeah. So I'll show you why, okay? So let's go over the distributive property one more time, and then we'll skip number 2 actually. Number 2 might be too difficult. If you guys got it, the answer is x cubed plus 3x squared y plus 3y squared, plus 3x squared y plus 3y squared x plus y cubed. Okay, so if you guys got it, good job. But let me guys show you number 1 first, okay? We'll skip number 2 though. So going over the distributive property again, remember how we said a times b plus c is equal to a times b plus a times c? Aiden, do you remember that?
Oh yeah, distributive property, yes, I know.
Yeah, okay. So now what about a plus b times b plus, sorry, a plus b times c plus d, okay? So if we treat this c plus d as one variable, right, then we can distribute it over a and b. Then we have c plus d times a plus c plus d times b. Does that make sense so far?
Yeah.
Yeah, okay. And then what can we do with these things? How do we expand them?
And do individually like AC plus DA, like A times C, A times D, then B times C, B times D.
Exactly. So this is what we get, right? AC plus AD plus BC plus BD. This one is equal to A plus B times C plus D. Does that make sense now? Aiden?
Yes.
Okay, so now do you understand why? Okay, so when we're expanding this, okay, we have to keep in mind. Let me use a different color. We can't just multiply these two by these two. If we treat this one as A, this one as B, this one as C, this one as D, right? Then x plus y squared is x plus y times x plus y. We have to multiply AC, AC. We multiply these two,
Yeah,
A,
foil.
yeah, AD, BC, BD, and then we add them all together, right? Did you do that? Aiden?
I said yeah.
Okay, cool. I didn't hear you because I'm not sure if it's my Zoom or your Zoom. Okay, but when you multiply these, from the first elements you get x squared, then you get xy from the outer elements, then the inner elements you get yx, then the last elements you get y squared, and that gives you x squared plus 2xy plus y squared. Does that make sense now?
Yeah, I know I know how foil works. I'm just kind of confused how like the other thing doesn't work for some reason. It just seems to not work compared to foil.
You mean
Yeah.
x plus y squared is equal to x squared plus y squared?
That doesn't seem to work for some reason.
Yeah, that's because it's not supposed to work. Um,
Yeah.
yeah,
It just doesn't feel like it just doesn't work for some reason.
yeah. So you guys keep in mind that x plus y squared never, okay, I shouldn't say never. It does not equal x squared plus y squared. The only case in which it is equal is when x or y is equal to 0. Okay, other than that, it's not equal. Okay, so Anthony, you typed in the chat that this number 2 was x cubed plus 2x squared y plus 2y squared x plus y cubed. But you did forget some terms. I'm going to go over it really quickly just because um, Anthony, you attempted it, okay? When we expand the first two, we get x squared plus 2xy plus y squared. We multiply that, times y times y squared, right? We multiply that by x plus y. Anthony, does this make sense so far? Now we multiply x squared by x squared by y, 2xy by x, 2xy by y squared by x, y squared by y. Does that make sense, Anthony? Can I get a thumbs up? Okay, cool. So once you expand all those terms out, you actually get 3x squared y plus 3y squared x once you combine the like terms, okay? You guys can try this on your own, but we're running a little bit low on time. Who wants to tell me really quickly what number 3, 4, and 5 are? Did anyone get these? Daniel? Michael's brother? Do you want to try
Oh,
number? Okay, Vincent, you can also go. Okay, so Anthony typed in the chat, this one is x plus y squared. And yes, that is correct. Because this is something you just have to remember, okay? X plus y squared is x squared plus 2xy plus y squared. And Aiden, I think. Aiden, you were raising your hand. Do you want to do number 4?
This is a method for this. This might not be with the same method as you guys, but basically what I did is just got the first, like, it's got the first number, the second number, the first number, and the third number, x squared and 36. I just chose 36 and square rooted it, so I made it into 6 to a 6 cubed. I mean 6 squared. I mean 6 squared. I changed it to 6 squared. Then I just put them together, and I got the answer. So x plus 6 in parentheses squared is the answer.
So this is actually another perfect square. It's a special case of x plus y squared where y equals 6. You see that 2 times 6 is equal to 12. That makes sense. 6 squared is equal to 36. That's why this one is x plus 6 squared. Makes sense? This one is a little bit tricky, but let's try number 5 and see if you guys get it. Anyone did number 5? And I'll give you guys a hint. It's also another perfect square. Aiden, you can do this one too.
This is very simple, like the first one. I just square rooted the 81 to turn it to 9, and that's 9 squared, and then I just do that x plus 9 squared. I mean x plus 9 in parentheses squared is the answer.
Exactly. Okay. So, whoops. Let me reshare. So today we're going to be learning about completing the square. Okay, so once you get a quadratic into one of these forms, x plus a squared equals b squared, or x squared plus 2ax plus a squared equals b squared. Do you guys see why these two equations are equivalent? Yes, no? Once you get it in one of these forms, you can just take the square root of both sides, and you get x plus a is equal to plus or minus b. You have to keep in mind you have two solutions, because when you square both sides, you can have the positive or a negative solution. For example, when you have x squared equals 16, for example, x can be 4 or negative 4, because negative 4 squared is 16, 4 squared is also 16, okay? Make sense? So that's why that's useful. Let's spend 15 minutes going over this really quick lesson, and then we're gonna move on to a quick game, okay? Hopefully a fun game. So try a couple of these problems. I'll go over the first couple, okay? Oops. The first question asks, solve for x. So x plus 2 squared equals 4. In this case, I would just take the square root of both sides. X plus 2 equals positive 2 or negative 2, right? Make sense so far? Remember, you have to keep in mind that you have two solutions. After that, you have x equals 0 or x equals negative 4. And those are your two solutions to this first equation, okay? Can you guys give number 2 a try? Did we do this on what, Monday? Just wondering.
No.
Okay, so let's give number 2 a try. Remember, the first step is to take the square root of both sides. When you see the right-hand side is a perfect square and the left-hand side is a perfect square, you can just take the square root of both sides. Does anyone know what the first step is? What you get after you do the first step?
Because you get the square root of 9, which is 3, and then the square root of the one in parentheses, and then you did that square root thing, so you don't and then you need to have a power 4.
Power of 4. Okay, so what else can 2y plus 4 equal? It can equal 3. What else can it equal? There's another value. Remember, I said you have to include the positive and the negative, right? So Daniel, what do you think the other value is? Is it negative 6? Is it negative 3? Is it 0? Or is it 9?
Negative 3.
Exactly.
Well, I think we did this on Monday.
Okay,
I remember negative 3 from Monday.
So quick review. Once you get to this part, then you can just subtract 4 from both sides, divide by 2, and then you'll find y. Once you get to that step, it's pretty simple, okay? Now, let's try some examples where you have to get this into a perfect square yourself. I'll do the first one. So you want to manipulate it into some form, x squared plus 2xy plus y squared, okay? Or x squared plus 2ax plus a squared, because remember, this is a perfect square, okay? A will be a constant, for example, 4 or 5 or 2, okay? And x will be the variable that you're solving for. And if we take a look at number 3, we'll see that this is already a perfect square. It's already done for us. This is in the form x squared plus 2a plus a squared, because a is just 2, right? If we write a here, if we can easily substitute it like that, right? So this means that the left-hand side is x plus 2 squared. Once we find x plus 2 squared equals 9, it's simple from here. We have x plus 2 equals 3 or x plus 2 equals negative 3. You solve it the same way as you did for number 1 and number 2, okay? So that's one example. Let's have you guys try number 4. And once you guys have any ideas of what you can do, once you see, you know, oh, hey, it's a perfect square, then tell me, oh, what can you do, okay? Jaden?
Yeah, since you said perfect square, that's basically the answer. So you do the thing where you just do 9 equals 3 squared, and then you say x plus 3 in parentheses squared is the answer. And no, not the answer yet. I'll write this down for a second. Okay, so then you can just do you can unsquare both 4 and the equation, so it's x plus 3 equals 2. X plus 3 equals 2. And you could say that x is better than 1, since 1 plus 3 is 2.
Yeah, and this symbol means plus or minus, okay? It means it can either equal plus 2 or minus 2. And do you guys see how this equation is in the form x squared plus 2ax plus a squared? This is just a special case of that, where a equals 3, okay? So once you get it in that form, then you can factor it out into x plus a squared equals 2 squared. Okay, let's try a couple more. So this next one is a little bit tougher, but keep in mind you can add or subtract to both sides of the equation, right, in order to make a perfect square. So x squared plus 4x plus 3 equals 8. When someone has an idea of what to do, maybe what to add or subtract from both sides to make a perfect square, raise your hand, okay? Or unmute yourself. Any ideas? By the way, it's this problem right here. Any guesses? Random guesses. It can be anything.
Minus 3 from both sides.
Okay, so keep in mind, if we have, remember, we want to get it into the form x squared plus 2ax plus a squared, right, on one side, and then some other number on the other side. Okay, it can be any number. For example, 64, or it can be 63, or it can be 21. Okay, any number on the right hand side. But we want to get it into this form on the left hand side. Okay, so what's the coefficient of x? It's 2a. So in this case, what's the coefficient of x? 4. So we have 2a equals 4 because we know that the coefficient of x is going to be 2a, right? 2a equals 4, we have a equals 2. So we want a squared to be 4. So on the left-hand side, instead of this 3 here, we want it to be a 4. How can we do that? Mary?
Add 1 to both sides.
Exactly. Okay, once we add 1 to both sides, you'll see that it's the exact same equation as number 3, right? This one is x squared plus 4x plus 4 equals 9. This one is, the bottom one is x squared plus 4x plus 3 equals 8. But if we add 1 to both sides, then we get the same equation. Then we get x plus 2 squared is equal to 3 squared. And we have x plus 2 equals 3, or x plus 2 equals negative 3. And to solve this, we would just subtract 2 from both sides. X equals 1 or negative 5. Okay, so same solution as the previous question, or actually 2 questions above this problem, okay? Okay, so last question that we're going to do before we move on to our fun little game. How do we do this question? X squared plus 4x plus 5 equals 3. Remember, we want to get it into the form x squared plus 2ax plus a squared on one side. And in this case, 2a is equal to 4. That should give you guys a hint. And the answers won't always be integers. Sometimes they'll be like irrational. Sometimes they'll have a root 2 in them even. So once anyone has an idea, just raise your hand or unmute yourself. Daniel, do you have a guess of what we can do? Remember, I want it in the form x squared plus 2ax. 2a is a coefficient plus a squared on the left-hand side, okay? I don't care what's on the right-hand side because I can just take the square root, right? So what is 2a equal to in this equation?
It's 2a is equals to 4x.
2ax is equal to 4x, but I'm only looking for the coefficient. So 2 is actually just equal to 4.
Then a is equal to 2.
Yep, a equals 2. So what can we do from here? So what is a squared equal to?
Wait, then it becomes this becomes a 2, and it just becomes a 4.
So a squared is 4. So we want this 5 to become a 4, right?
Yeah, so wait, but right now it becomes x squared plus 4 or what?
Yeah, so we keep 4x on the left-hand side, right? So what can we do to both sides to make this 5 into a 4? How do we make 5? How do we turn it into 4?
Minus 1 from here, which becomes 2, and minus 1 from here.
Exactly, okay. So let me erase this so we have a little bit more space to work with. So now what's our new equation?
The new equation is...
Yeah, we have a perfect square on the left-hand side, right? X squared plus 2 times 2x plus 2 squared equals 2, right? And the left-hand side is a perfect square. That's why I want it in the form x squared plus 2ax plus a squared. So I can take the square root, right? So now that I have x plus 2 squared, this one equals 2. What can we do to both sides? We can take the square root, okay? So we have x plus 2 equals plus or minus root 2. X equals negative 2 plus or minus root 2. Okay, and that is the end of our lesson. Actually, I do have one more slide. Okay, does that make sense to everyone so far? Daniel, does that make sense to you? If you have any questions, feel free to ask.
No.
No questions? Okay, cool. So here is the derivation of the quadratic formula. And this is like a shortcut that you can use. It's not really a shortcut. This is a method that you can use to solve any quadratic equation without fail, okay? And you start with the first equation, ax squared plus bx plus c. But you want the coefficient of x squared to be 1, right? So you just divide both sides by a. You can divide both sides by a because the right-hand side is 0. 0 divided by a is still 0. Okay, so the first step, you're just dividing by a. Then you move negative c over a to the right-hand side. From this step to this step, all we're doing is subtracting c over a from both sides. Then we want to complete the square, okay? In this case, we have b over 2a is our a, like what we used as a before, x squared plus, if we want it in the form x squared plus 2ax plus a squared on the left-hand side, this b over 2a is what we want it as, okay? Is our a, if that makes sense. I should probably use a different variable. So for example, if I wanted it in the form x squared plus 2px plus p squared, where p is just another variable, right? This is a perfect square. This is equal to x plus 2 squared. No, sorry, x plus p squared. Does that make sense? And in this case, b over 2a is just p. Can you guys see that?
Yeah. Wait, what? I have a question.
Yeah, sure.
Oh, I understand it.
Oh,
I thought that the b over 2a was b over 3a.
oh yeah, no problem, okay? So this left-hand side can be rewritten as this, okay? In the right-hand side, we just add the fractions using common denominators. We have 4a squared as a common denominator, right? And then we take the square root of both sides, just like we did before. Square root of 4a squared is 2a, so we can take that out of the square root. Can you guys see that? Before, the square root extended all the way to the bottom, but now it only extends in the numerator. But remember, you have to have this plus or minus sign, okay? Then we subtract negative b over 2a from both sides. And our final answer is x equals negative b over 2a plus or minus square root of b squared minus 4ac over 2a. So it's a little bit complicated, okay? But you guys can Google quadratic
I
formula.
don't understand what the plus or minus thing even mean.
Yeah, plus or minus means you can add it or subtract it. Both are solutions, okay? Now what happens if, quick, more advanced thing, okay? If what's inside the square root is negative, then you won't have any real solutions. The quadratic graph, it'll look something like this, okay? It won't be touching y equals 0. And what that means is you don't have any real solutions. Okay, you don't have any solutions. Now that we're done with that, we won't have any questions in our little game about the quadratic formula, okay? But this is something useful to know how you can derive it. We derived it using completing the perfect square, okay? Which is how we solved all the other quadratic formulas, quadratic equations. So with that said, we're gonna be doing a quick game, okay? So we only have like 23 minutes left. So we're gonna be doing this game, and each question is 1 point. And at the end of this game, the person with the most points will win. Got it? So with that said, let's start. 23 minutes. I think we have about 12 or 13 questions. And the first person to raise their hand or just blur out the answer will get a point. Anyone know the answer to number 1 yet?
14 pi.
Exactly, correct. Okay. Daniel, next time you don't need to raise your hand. You can just, I think blurting out will be easier for everyone. Let me annotate. Yeah, exactly. So the area of the circle is pi r squared, right? Which equals 49 pi. If we cancel out the pi on both sides, we can cancel out because we're just dividing by pi on both sides. We can see that r squared equals 49. When we take the square root, normally you'd have to take the plus or minus 7, right? You can have positive 7 or negative 7. But in this case, you can't have a negative radius. So the radius is just 7. Now the circumference is 2 pi r. Now we just substitute 7 in, and our circumference is just 14 pi. So Vincent got a point. Congrats. Next question. The two triangles are congruent based on what congruence theorem? And keep in mind, we have a couple congruence theorems, okay? We have side, side, side. We have side, angle, side, side, sorry, angle, angle, side, and I think it was angle, side, angle.
Side, angle, side.
Side, angle, side.
Sorry, who said that first? Wait, sorry, I didn't see the name pop up. Was that you, Vincent?
I said it, but I don't know if you said it before me.
Oh, okay. I heard your voice first, I think. Okay. Uh-oh. We might have to give Vincent a handicap. I'm just kidding. Okay, so now we're gonna graph the equation y equals 2x plus 1. So how we'll do this one is we'll just have you guys all try to graph this. Once you guys think you know how to graph this, just say I'm ready. And then I'll let you guys annotate.
I'm ready.
Okay, Mary, let's go. Let me draw the coordinate axes. Oops. That was fast. Okay. Is this good enough? X is on the horizontal axis, Y is vertical. Okay. Mary?
Each tick mark stands for 1, right?
Yeah.
Okay.
Yeah, exactly. Sorry, it's a little hard to draw, right? Because we're not on an actual pencil and paper. But if we use a different color, it passes through the points 0, 1, passes through the point 1, 3, 2, 5, -1, -1. And you can do that by just plugging in. When you plug in -1 for x, you get -2 plus 1, which is -1. When you plug in 1 for x, it's 3. When you plug in 2 for x, you get 5. Does that make sense to everyone? The line would look something like this, although we can't really draw. Make sense? So good job, Mary. Did everyone else get that too? Okay, let's solve this system of equations. So again, right here, we're looking for x comma y.
Wait, could we just shout it out or something?
Yeah, sure.
X equals 4 and Y is 8.
4 and y equals 8.
Okay, so Oh, Anthony typed it in the chat. Okay, so I guess I have to give the points to all of you. Wait, did you guys hear did Daniel or Vincent say it first? Okay, I'll give the point to both of you guys, or all three of you guys. Anthony, Daniel, and Vincent. Good job, guys. The reason how you saw the method you used to solve this, I think the most straightforward method is substitution. You just have 3x equals 12, right? You substitute y equals 2x into the first equation, you get x equals 4. Then you substitute x into the second equation, and you get y equals 8. So our final answer is 4, 8. Sound good? Okay, so this is the next question. Let me draw it out. This one is a bit trickier. And again, once you have the answer, just unmute yourself and shout it out. Did any of you guys attempt this? Any ideas?
I was just to find the area of this triangle.
Yeah.
It's the normal triangle formula, right? Just like it's like 5 area square, but divided by 2.
Yeah.
So
what do you think the answer is?
length times width divided by 2.
So what is the length?
The length is 3, and the height. To get the height, I think you need the Pythagorean theorem.
Sure, let's try that. Okay. So how do you do that?
Wait, no, not the Pythagorean theorem. That's the wrong thing. Oh yeah, like kind of like the Pythagorean theorem, but reversed, kind of.
Yeah, that's still the Pythagorean theorem. Okay, so let's try it. So this length, since it splits it down the middle by symmetry, right?
3 divided by 2, yes.
Yeah. So what's the height? Let's call it h.
So height, okay, height square. So like to get the hypotenuse, you need to do a squared plus b squared equals c squared. So in this case, c squared, c equals 3, so c squared is 9. And 3 over 2 squared, that's 3 over 2, multiplied by 3 by 2, that's 9 over 4.
Then
which is basically the same thing, actually. Wait, is that the same thing, basically? Okay, so yeah, 9 over 4, so you just do 9 minus 9 over 4. Once you do that, so to like convert that, yep, and then yeah,
so what'd you get for h?
so just like again, I need to turn 9 to fractions, so 9 over 1 multiplied 4 on both on top and bottom, so 36 over 4, and 36 minus 9, 36 minus 9 is 27 over 4, and you just do square root that, I think.
Yeah, so once you take the square root, you get 3 root 3 over 2. And then how do you find the final answer?
But answer h. Oh yeah, you just the length times width divided 2.
Okay, so we multiply this one by 3 and then divide it by 2, right?
Yeah.
So the final answer should be, I think, something like 9 root 3 over 4. Did anyone else get that? Did anyone else not get that? Okay, cool. I'm gonna assume everyone got it then.
Hey, can I just tell you something weird?
Huh? Daniel, did you say something?
Yeah, I wanted to tell you something. I was like thinking of I was thinking of the formula and I went to search it up.
Oh. Yeah, so the Pythagorean theorem is just a squared plus b squared equals c squared. And you have to construct the right triangle in this example, okay? You can just draw a line down the middle. A lot of times in geometry, you have to add some lines. And a lot of times when you see some symmetry, you can add a line down the middle. So this next question, it's a word problem. I buy X markers for $3 each and Y pens for $2 each. I spend $8 on 3 markers and pens total, okay? So find the number of markers and find the number of pens that I bought.
2 markers, 3 pens.
Jerry? Oh, good job. Okay, cool. How'd you get?
I just guessed.
Sorry, can you read? What'd you say?
I just like tried it out.
2 markers and how many pens?
2 markers and 1 pen.
So let's try that, okay? 2. Okay, let's here. So I think that is correct, okay? So when we buy 2 markers, it's 2 times 3 is 6. When we buy 1 pen, it's $2. So we have $8 spent, and 2 plus 1 is 3, okay? So let's try to write equations. If we have $3 each for markers, for X markers, and we have X markers, right, then that's 3X dollars, and then $2 per pen times Y pens, and that should give us a number of dollars, which is 8. Then we have X plus Y equals 3, okay? Then we just subtract a multiple of the
You just guessed because there's only 2 possibilities.
Yeah. Okay, so good job. So good job, Jerry. That was really fast. I have 3 physics, 2 chemistry books, and 1 math book. I want to arrange them on a shelf. Okay, so I have 6 books that I want to arrange on the shelf. How many ways are there to arrange them if books of one subject must be placed together? So for example, all the physics books have to be placed together. This is a counting problem. And here's a... Sorry, what?
6.
Close, but can you explain your reasoning?
Because for the first number, or for the first like subject, there'd be 3 options. For the second, there's 2, and there's 1 for the last one.
Yeah, okay, but you also have to keep in mind that within the physics books, you have 3 different physics books, right? So you can have, like, let's say you have physics book A and physics book B and physics book C. You can arrange these in multiple different ways. So you also have to keep that in mind.
64.
64?
No, wait.
Okay, it's okay. Anyone have any ideas? Samuel?
Is it 9?
Close. Here, I'll give you a hint. Okay, so there are 6 ways to arrange the subjects. Okay, so you can have like physics, chemistry, math, physics, math, chemistry, chemistry, math, physics, chemistry, physics, math, or math, chemistry, physics, math, physics, chemistry, right? So those are the 6 ways to arrange the different subjects. But within these different books, right, we can arrange them in different ways. So Samuel, how many ways do you think are there to order 3 physics books?
Four or six, I mean.
Yeah, 6 ways to order 3 physics books, right? And we have 6 ways to order the different books on the shelf. How about 2 chem books?
Two.
And how about 1 math book?
One.
1. So what do you think the final answer is?
72.
72. Exactly. Okay, good job. I believe that's correct. Someone correct me if I'm wrong, by the way. Okay. Next question. So Joe rolls a die, 1 die, and he flips a coin. What is the probability that he rolls a 3 or more and flips heads?
A fourth.
Sorry, can you repeat that? The audio cut out a tiny bit.
A fourth.
1/4? Sorry, did you say 1/4?
Yeah.
Sure. Can you walk us how you did that? Walk us through how you did that.
To the probability of rolling a 3, 4. Oh wait, no.
It's okay. You're really close.
A third.
Exactly. Okay. So the probability of rolling a 3 to a 6, you have 4 numbers that satisfy the condition out of 6 total numbers, right? Because you can roll a 1, 2, 3, 4, or 5 or 6. If you multiply this, sorry, since they're independent probabilities, you can multiply them. You multiply this 4/6 or 2/3 by 1/2 because you only have heads or tails. I forgot to say that it was a fair coin, but you can just assume that. Once you multiply these two, you can see that it's 1/3. So that means if you roll it 3 times, you'd probably expect it to land on you'd probably expect it to roll a 3 or more and flip heads 1 out of 3 times. Okay. 2 similar triangles have areas 1 and 5 respectively. What is the ratio of the perimeter of the larger triangle to the smaller triangle? This one is a bit trickier. It might be the last problem that we do, unfortunately, because we're running a bit low on time. Anyone want to give this a shot? When we draw the 2 triangles, let's say we have one triangle like this, another triangle like that. This is area 1, this is area 25.
1 to 5.
Yes, so the ratio of the larger to the smaller would be 5 to 1, okay? Because, for example, let's say the larger triangle has base 5b and height 5h. This one, if this is 25, then the small triangle would be b times h over 2. And if we manipulate this one, let's just divide both sides by 25, it would give us 1. Does that make sense? I should have started the other way around. For example, if I started with BH over 2 equals 1. Then 25 BH over 2 would equal 25. Basically, the ratio of the perimeters squared is equal to the ratio of the areas in general. For volumes, the ratio of the perimeters, well, you don't really have a perimeter for volume, but the ratio of one side length to another, when you cube that, that's the ratio of the volumes. But that's for 3D figures. Let's do one more problem to see if you guys can get it. So this is the last problem that we're going to be doing today. And I'll give you guys a clue. For the first problem, the left-hand side is a perfect square. So you can do something with that. Any ideas? I'll do the first step. Okay, so we can write it into a perfect square. Now we can write it as x equals negative y. And this should give you some ideas. Substitution, maybe? Aiden, do you want to take it from here? So we have the two equations, x equals negative y, and 2x plus 3y equals 4.
What? I thought you're solving the ones on the that's shown on a slide, or are you the one that you're drawing right now?
Yeah, so this first equation on top is actually equal to the equation x equals negative y. They're exactly the same.
Oh, so you want, okay, so take it from here. Let me see.
We can substitute x equals negative y into the bottom equation, right?
Right, because we can use, because 2x, we could say 2x is equal to 2 negative y, and negative 2y, since x equals, no, because the 2x, that'd just be 2y, right? 2y plus 3y equals 4.
X equals negative y. So it would be negative 2x plus 3y equals 4. Then we have y equals 4. So what does x equal?
I was just thinking, I can turn 2x into like negative 2y or 2y or something like that. They'll find y, then find x.
Yeah. So when you're given y equals 4, how do you find x? We can substitute it into this equation, right? So what do you
Well, if x equals negative y, then x is negative 4.
Yeah. So our solution is negative 4 comma 4. Okay. Make sense? Cool. Okay, so that was the last problem that we're gonna do. Let me stop our share. So it's 4:02 actually. I went 2 minutes beyond our time limit. So thank you guys for sticking around for all 10 courses, okay? For all 10 classes in our course. Today is our last final day. If you guys want practice in the future, you guys can take a look at our videos, which Michael sent out in a Google Drive folder, okay? Those are pretty useful to watch. And then once you watch those, if you do have any more questions, feel free to message, email, or WeChat me or Michael, okay? Sound good? With that said, oh, thanks, Jerry. Very nice. Okay, so with that said, thank you guys all for sticking around for all 10 classes, and we hope to see you for a different course, okay?
Thank you. Bye.
Bye-bye.
Bye-bye.